Hey everybody, it's covalent bonding. Woo woo woo! So we're talking about bonding. So so here are the objectives that we're going to be looking at. Okay, drawing loose dot diagrams, properties and characteristics of bonding, a molecular formula, and a molecular structure. So what do you want to bond? That's what's going to happen here. We're talking about bonding. Read those sections through that page, answer this and this, okay? And there's going to be another question at the end, all right? So let's get busy talking about why do atoms bond. So sodium has one outer electron. Chlorine has 7 outer electrons. Why would they bond? Well, if sodium gives up one outer electron, then its inner shell is full, stable. If chlorine takes one outer electron, then its outer shell is full, stable. So why do atoms form bonds? To have full valence shells. This is the kind of bond we're talking about next unit. But look at this. Look at fluorine. 1, 2, 3, 4, 5. Oh, hey, what's that? 6, 7. Fluorine has 7 valence electrons. So what can chlorine do to be stable? I said chlorine, I meant fluorine. Well, fluorine can share with another fluorine, and if they overlap their outer energy levels, and then this red one counts for the left fluorine and the right fluorine, and blue counts for the left and right, and then 1, 2, 3, 4, 5, 6, 7, 8. By sharing, each atom has 8 valence electrons. So that's the kind of bonding we're talking about first. How can we show atoms and what they want to do with their electrons? Well, there's a way to do it called electron dot diagrams, okay, that help us picture what atoms are doing with their valence electrons. Step 1, find the atom on the periodic table and write the symbol, all right? And then use the dots for valence electrons like so. So I'm going to pick nitrogen. Now look, it's in column 5A. So that how many valence electrons? 5 valence electrons. So you go ahead and put the valence electrons around the symbol, and one at a time until you have to double up. So there, 5 valence electrons around nitrogen. Okay, we'll keep going. So that's what's been done for all of these elements. Look, group 1A, 1 valence electron. All of them have single dots on their sides. 2A, 2 valence electrons. All of them have 2 dots. Notice they're not doubled up because you put one around until you have to double up. 3 valence electrons. 1, 2, 3, 1, 2, 3, 1, 2, 3. 4 valence electrons. 1, 2, 3, 4. All right, etc. Now the only one that's a little weird is helium. It only has 2 valence electrons, and so they're double dotted because it fills a shell. But that's it. Then if you look at fluorine, 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. So each dot represents an electron. So what can you learn from these? Well, we did nitrogen on the other slide, and here we can tell how many bonds that these atoms are likely to make. So we look at it, we count the single dots, 1, 2, 3. Nitrogen has 3 single dots, so it can make 3 bonds usually. All right, let's go find chlorine. Chlorine has 1 single dot, so how many bonds will chlorine make? 1 bond. All right, hydrogen, 1 single dot. How many bonds would hydrogen make? 1 bond. Okay, so single dots equal bonding sites. So you can predict how many bonds an atom's going to make by looking at its dot structure. Now it's just a prediction, it usually works, but that's what we can do. Okay, so there's 7 elements on the periodic table that when they are elemental, that means by themselves with no other elements, then they are what we call diatomic. Di means 2. Those 7 elements are nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. So I just say the word nafkulbri just to pronounce all of the symbols in that name, in that word. And then it helps to remember that element number 7, 8, 9, 17, 35, 53, and 1. Okay, look, it makes the number 7 on the periodic table and points over to hydrogen. Those 7 elements, when they're elemental or by themselves, they're always actually together. So nitrogen will always be N2. Oxygen will always be O2. Bromine will always be Br2. Okay, so how do you remember which 7? Nafkulbri. All right, so you know that friend that always wants you by their side? That's diatomic, always together. So I looked up some funny sounding words. Here's one, bumfuzzle. That's funny sounding. Okay, use it today. Lewis dot structures. So we go from a Lewis dot structure of an atom to a Lewis dot structure of a whole molecule. So what you do is you figure out what each atom will look like. So hydrogen is that. Why am I only putting 1 dot? Because it's in group 1. It only has 1 dot, but there are 2 H's in that molecule. Okay, and then oxygen has 1, 2, 3, 4, 5, 6. How do I know? Group 6A, 6 valence electrons. Look, single dot, single dot. That helps us know where the hydrogen is going to bond to the oxygen. So then you could go ahead and put the atom that can make the most bonds in the middle. 1 dot there, 1 dot there. Hydrogen's dot, and any dots that are used for a bond become a line. So a line represents 2 electrons. And then this is the dot structure for H2O. All right, do it for H2S. Well, there's H again. Oops, I draw S. 1, 2, 3. Well, let me do it going around. 1, 2, 3, 4, 5, 6. Look, sulfur can make 2 bonds. Hydrogen can each make 1. So then we line them up. I have to keep drawing. Oh, come on, let's hold on, get all that together. All right. And then wherever there's 2 dots in between atoms, you erase it and you draw a line, and that line represents 2 electrons making a bond. So lines are bonds. That means hydrogen gets to count those electrons around itself, and sulfur also gets to count those electrons. Okay. Diatomic. So we just got done doing off, cool, breathe. So let's pick hydrogen. Hydrogen's like this. All right. This just means H2, so then we would line up the 2 hydrogen atoms, and then this pair of electrons can be shared between them, and so it makes a bond. So here is the dot structure for hydrogen, H2. Dot structure for water, Lewis dot structure for H2S, and we can do it for all of the diatomics. So let's do fluorine, just so we can see it. Fluorine has 7 dots. How do I know? 7 valence electrons, periodic table group 7A. So diatomic means F2, so I'm going to line it up so that the single dot is next to the other single dot, and then I'll erase those 2 dots and make a bond. So here's the dot structure for F2. Okay, so we use Lewis dot structures to help represent covalent bonding, to help represent atoms. So here's a few more. We'll do one together. Here's how you decide for a molecule. You put the atom that makes the most bonds in the middle. So looking at carbon, I know it has 4 single dots. Hydrogen only has 1 single dot. So to make this molecule, I'm going to put carbon in the middle with its 4 single dots. Hydrogen, 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 hydrogen. Each hydrogen brings in a single dot because it's in group 1. And then you can erase all of the ones that were 2 and make it a bond. So each line represents 2 electrons. How do you know if a dot structure is good? We'll talk about that in class. But look, carbon has 2, 4, 6, 8 around it now. 8 is great. Happy carbon. Hydrogen is such a small atom, it only needs 2 electrons around it to be stable. And if it's brought its own and sharing one of carbons, it has 2 around it. Okay, let's do NH3. N looks like this. H looks like this, but there's 3 H's. All right, so how are we going to put them together? Well, let's line them up and connect the dots. La, 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 la. 2 dots make a bond, so 1 bond. Okay, 2 dots make a bond, 1 bond, 1 bond. So nitrogen has 1, 2, 3, 4, 5, 6, 7, 8 around it, stable. You got to make sure you erase the dot when you draw the line. Hydrogen only needs 2 to be stable. We'll practice those 2 in class. Next, now, what we've done over here, each line represents 2 electrons, so that is called a single bond. All right. So how do atoms make molecules? Well, they could make a single bond and share those electrons. That's 2 electrons, single bond. But not all bonds are single. You can have double bonds, and a double bond is where 4 electrons are shared between 2 atoms. So double bonds are stronger. They're not 2 times stronger, but a double bond pulls atoms closer together, so it's harder to break that bond. So it's a little shorter than a single bond and stronger. Triple bonds, you can have 6 electrons that are shared. Those are stronger than single and double bonds and shorter than single or double bonds. Okay, so not all bonds are single, and there are quadruple bonds. So remember, double bonds, 4 electrons, triple bonds, 6 electrons. I can show you what that looks like. Okay, so when we're talking about bonds, and we're talking about bonds between atoms that are sharing those electrons, so they count for each atom, it's called a covalent bond. Co-share. Aw, share. Woo, sharing electrons. What kind of atoms want to share electrons? Well, 2 nonmetals want to share electrons because their electronegativities are pretty close to each other. And so the way they can become more stable is by sharing electrons. So make sure you know we are called covalent bonds where they're sharing electrons directional covalent bonds because they're stuck in between the 2 atoms, meaning that they can't freely move. They're in an area between the atoms. It helps the atoms fill an octet or get 8 because 8 is great. Okay, and then the shared electrons count for each atom. We did this on the other page. This is a molecule that looks like this. So these 2 electrons, one was from nitrogen, one was from hydrogen. They're shared, and so hydrogen's using them and nitrogen's using them. Okay. All right, so here's important characteristics that come from this kind of bonding. So covalent bonding is also known as molecular bonding, happens between 2 nonmetal elements. Okay, the valence electrons are shared. Because electrons are shared and they can't be moving through something, they do not conduct electricity. And a lot of these substances have low melting points. That can vary, but they could have low melting points. We'll learn about this a little bit more, but if there's polar covalent compounds, they could dissolve in water, but if they're nonpolar, they won't. Many can be solids, liquids, or gases. When substances form from these kind of bonds, they could be solids, liquids, or gases, but this is the only type of compound that could be liquids or gases at room temperature. Okay, all elements, if 2 of the elements bonded together are the same, then you're talking about an element. But if the atoms are different, you're talking about a compound. So you can make compounds and elements that have this kind of bonding where they share electrons. Okay, so how do we represent these molecules? There's something called a structural formula. A structural formula shows how atoms are arranged and which atoms are bonded to each other. And there's something called a molecular formula. A molecular formula tells the count of atoms that are in the molecule. Okay, so here's a formula and here's a formula. Which is which? Well, this shows how the atoms are connected. So this is structural. This shows how many atoms are in it. So 1, 2, 2 carbons, 1, 2, 2 oxygens, 1, 2, 3, 4, 4 hydrogens. So this is molecular. Okay, I want you to try telling me which one of these is which is which. And you may see that on an open note quiz because I want to know if you can tell me. Okay, so let's match. All right, CH4 molecular because counting atoms. CH4 structural. Okay, oh look, it's matching up. Okay, F2 counts the atoms. This shows how they're connected. H2O counts the atoms. This shows how they're connected. And then that shows how they're connected. This should be 2 dots like that. Okay, so give molecular formulas for these. Try it, count them. H2, 2 H's, O2, 2 O's. You try. So this is structural because you see how they're connected. You want molecular. Okay, so please read sections 8.1 and 8.2 in the book through page 22, 222. All right, so here's your end question. Look in the book and read about the octet rule, okay? Now, I mentioned the octet rule by giving a number and a saying for it, okay? And then make sure you look up the book definition. What kind of atoms from the periodic table usually make covalent bonds, okay? Give groups on the periodic table and tell me what kind of atoms those are. So look at a periodic table, give group numbers, and then what kind of atoms those are in those groups, okay? All right. Anyway, I hope you learned how to do this. Describe covalent bonds and molecules. Draw loose dot diagrams for atoms, ions, and compounds. We'll do ions in class. Apply the octet rule. Okay. Explain the difference between single, double, and triple covalent bonds. Number of electrons. Why bonds form. And the difference between a molecular and structural formula. All right. Hope you had fun. And I played this song because what atoms want to do is they totally want to bond. All right.